Hi, my name is Kevin Curry. Today we're going to be talking about combining like terms. This is just a review, a little algebra mix in there to help you out. I have my own website, currymath.weebly.com. It is a strictly algebra site right now. This video will probably be the first one posted on there. So I'm starting from Unit 2. Unit 1's more pre-algebra, adding, subtracting, multiplying, dividing, stuff like that. So we're going to start off more pre-algebra right here, getting into algebra, combining like terms. So a little bit of vocabulary here. Variable. We have that is our letter term. You might see it written as X most likely, or Y. We have a coefficient that normally goes with each term. This would be your number, and it shows multiplication. Multiplication there. So generally a term here, which is a variable and coefficient together, would look like something like 3x. It could be negative x over 7. Right, it looks something like that. This right here is our variable. Pardon my handwriting. This right here, coefficient. Now definitions are important because the more words you know, the easier it is to communicate what you're trying to say. So if I say coefficient, I'm talking about the number in front. If I say variable, I'm talking about the letter term. Okay. Now like terms, your last definition for this lesson, like terms. And again, if I'm moving too fast, you always pause the video, copy down any definitions you might need. Like terms are terms with same variable and same exponent. So they're the same variable, same letter. They also have the same exponent, which is not the same as a coefficient. So here if we have 3x, this is really 3x to the first. Here we have 3x squared. These would not be like terms. Now you say the coefficients are the same, right? Same coefficients, and I'll abbreviate this. Same variable. Right. Do this one in blue here so you can see. This right here, I like to think of them as stamp numbers. This is our exponent. Exponent here is 1. It might not always be written. You can assume that it's going to be a 1. Here it's 2. Different exponents. So these are not like terms. There's a non-example of like terms. Example of like terms could be 4y and negative 6y. Here, again, these are exponents 1, exponents 1. Here we have the same variable. Same exponent. And we look back to our definition. Like terms with the same variable and the same exponent. Now you notice here 1 is 4, 1 is 6. These are our coefficients. Those are allowed to be different. Can be different. In fact, they likely will be. More times than not. So that's your basic definitions for like terms. Let's take a look at some examples here. We'll skip that section there. That's more classroom. Got to be in class to get that. We're going to go down to the back side of our page. I'm talking about problem numbers 1, 4, 7, and 13. I like to set up my notes in 3 columns where I'll do the first column. We in class would normally do the second column. And of course you would be left, the student, to learn about the third column. That's how the majority of my worksheets are set up. So let's do these 5 problems here. First one, x plus x plus x. Right, 3 variables. Right, same exponents, they all have the exponent of 1. If it helps you to always throw those in there. X to the first, same variable, same exponent. We can combine these. 1x plus another x is 2x. Notice how I say structured here. Plus another 1x. Only doing one thing at a time. 1 plus 2, 3. Make sure you keep that x right there. So this expression will simplify to be 3x, right? If you have 3 x's, if you have 3 oranges, you have 3 oranges. If you have 3 apples, 3 apples. If you have 3 x's, 3x. Okay. Number 4. We jump into a little bit more difficult. We could do this on this side over here. We have negative 6y plus 8 minus 2y minus 4. So here's number 4. Again, you could get all these worksheets and much more practice on my website, currymath.weebly.com. If you need any help, you can tweet at me at Mr. Kerr. I respond to those quite frequently. So here we have some terms. We have a y term. Do we have any other y terms in our expression? The answer is yes, right? So let's put a box around those. We have negative 6y. Remember the coefficient, the number, and the letter make up the term. We have a negative 2y here. So we combine these like terms. Negative 6 and a negative 2 make a negative 8. Same signs, add and keep. Can we combine our numbers? Right, numbers are their own term. They're constants. You can combine them. And we're used to that, right? When we were growing up, we would just do simple math. 3 plus 2. Well, those are like terms. We know that that is 5, so we were able to do that. Here we have 8. Take away 4. That'll leave me with a positive 4. Now, what did I forget here? Yeah, I forgot my letter, right? So when you combine like terms, keep that variable and the exponent the same. We're going to make this a negative 8y. Can I combine my y's and my 4's? No, they don't have the same variable, so this will be my final answer. When we get into working with equations, we'll be able to solve for just y and see what y is in each circumstance. Okay, so that's 1 and 4. We're going to do 7, 10, and 13. Number 7, negative 2x squared. This is number 7. Plus 5x squared. Minus 7. Plus 4. And you want to identify your like terms. Same variable, same exponent. We have x to the second power, x to the second power, just a number, and just a number. I have some repeats here, right? So my variables x squared can combine. Add the coefficients, negative 2, positive 5. Take the sign of the higher number always. Opposite signs subtract. We're left with a positive 3. Make sure you keep your variable. So let's keep x squared right there. We combine those first two. Take a look at your original problem. We did these. Can we combine negative 7 and positive 4? Are those both like terms? Yes, they are. So negative 7 plus 4. We will combine those. Take the sign in the higher number. Minus 3. Can I combine 3x squared and negative 3? I can't, right? This has a variable of x squared. This does not have a variable of x squared. Therefore, they're not like terms. Yes, they have the same coefficients, but that's fine. That is our final answer. Okay, number 10 and 13. The last problems we'll do here. I'll try to squeeze both of them up here on this very, very small board. Now this is such a small board. Number 10. 6b plus b minus 5b minus b. A lot of different ways you can do this. Let's take a look. Can we identify like terms? We need the same variable, the same exponent. 6b, b, negative 5b, negative b. I hear a lot of b's. Buzzing like a bee. 6b, and 1b, right? If there's no number there, we're going to assume that that's a 1. Let's combine these. 6 plus 1, 7b. Now let's take our time, right? Minus 5b, we just bring these down. And start the process all over again, right? 7b, negative 5b, negative 1b. I can combine my 7b and my negative 5b. 7, take away 5. We add those coefficients. 7 take away 5. I'll be left with 2b. Let's bring down our minus b one more time. We've taken a very large problem, consolidated it, simplified it down to just these last terms. Can I combine these? Absolutely. We'll make that a negative 1b. 2b, take away 1b. You're left with 1b. My final answer. Do I need to write 1 in front of there? Not really. No. College students do not write that. They just write b. It's understood that it's a 1. And last problem we'll do for this lesson here. Again, you can do the middle column and the last column. 10 solid practice problems to make sure you understand the concepts that we're doing. Let's do number 13 to end it out. I also have a challenge problem on this worksheet. For those of you that might be working ahead. 5x squared plus 4x minus 3x squared plus 3x plus 6. Might squeeze it in there. Identify like terms. Think back, and you can look back to your definition, but you should be starting to get the hang of it. Like terms, two things have to be the same. The letter and the exponent. The little number and the letter. 5x squared. Do you see another x squared in my problem? You should. I see one. A negative 3x squared. So let's take care of those first. 5x squared. Keep the sign and the number of the coefficient. That's a negative 3x squared, not 3x squared. Negative 3x squared. Let's combine those. 5 take away 3. That's a 2x squared. 2x squared there. Let's bring everything else down. It's getting a little tight up there. So 4x will come down. 3x will come down. Positive 6 comes down. Ask yourself, x squared, do I see any more x squareds? No, I don't. There could be, but there's none in this problem. 4x to the first power. Yeah, 4x to the first and 3x to the first will be like terms. So let's add 4 plus 3. That'll give me a positive 7x. I said this has no like terms, so let's bring that down. 2x squared. My plus 6 on the end will come down. Plus 6. Final check. Are there any more like terms? I see I have an x squared and an x. Like terms? No, they're not because of the exponent. This has a squared exponent. This is just to the first power. This will be our final answer. So I encourage you to do the final 2 columns on that worksheet. There's also a practice worksheet under the same lesson on my website, currymath.weebly.com. Kevin Curry, it was a pleasure. Keep studying, you can do it.